Let me check if we are live or not. Hey everyone, hi, hello, welcome to Unacademy ICSE and ISC YouTube channel. So today we are going to do, So today we are having properties of water along with the important MCQs from water. Okay, so this is Manisha and these are my credentials. I have done my graduation and I have also done my diploma in electronics and electronics. So I am a gold medalist in both. I am a plus verified educator. I was university and state topper. So all these are my credentials. Okay. So these are the links of Telegram channel. This is the link of my Telegram channel. So which you can join for the class notes related to every YouTube session and the homework page. Okay. And this is the official Telegram channel of Unacademy ICSE and ISC board. On this channel, you will be getting the links of every class, the important notifications, the latest offers that come on Academy and everything. Okay, so do join this channel so that you receive all the important notifications related to your exams and all. Okay, so just let me know once if anybody is there, if I am clearly visible and audible to everyone. Yes. Just let me know once if I'm clearly visible and audible to everyone. Yeah? Okay. Chalo. So, Unacademy has free special classes on the app. In these free special classes, you can have like real time interactions with your teacher using the chat and emojis. You can ask questions using the question tab. You can go for live polls, okay? And you can also observe the poll leaderboard where you can compare your rank with your friends and you can know the level of your preparations, okay? So again, these are the amazing benefits that you have with your free special classes. These are absolutely free. You don't have to pay anything for these classes. Okay. Hello Shaurya, welcome to the class. Ma'am, please do nitric acid. Yes, Shaurya, I will do the nitric acid chapter. Don't worry about that. Okay. So, okay. And special class timetable is as follows, like 16 today we have a revision on study of gas laws. Okay, then on 18th you have a poll war, that is previous year questions from gas laws and numericals as well. And on 21st we have revision on water on Unacademy special class. So for class 9 the special classes is from 5:15 to 6:15 p.m. Okay, so you can certainly join these classes and you can understand, you can take participate in every class and you can do the revision for your exams. Okay, and you can also practice previous year questions. So there are many advantages of attending the special classes. Okay, so please let me know if okay. Okay, so let's start. Okay, so anyone who wants to go for more benefits, more better classes, more doubt solving sessions. Okay, so all these you can do through Unacademy subscription. So we have Unacademy subscription where you can avail so many benefits, like you can have practice tests, study materials, you can learn live from the comfort of your home. Okay, top educators of India are teaching on this platform, regular doubt solving sessions we have. So there are so many things that you can really have benefit from and can really prepare yourself well for your exam. Also, we have Unacademy Plus subscription at very affordable price. We have subscription starting from 3 months to 36 months, okay? And if you take subscription for class 9, no, you will be getting 10, 11 and 12 subscription for absolutely free. You don't have to pay anything. So with single subscription, you can have access to all the courses of 10, 11, 12 as well. And do not forget to use my code Manisha Live, which will not give you a 10% discount, but this time using my code will give you 20% discount. Just imagine, this is the greatest discount ever, okay? And this offer is till your 16th of Feb, so do hurry and take the offer, that is today, okay? And use my code to avail this offer, that is 20% discount, okay? So use my code Manisha Live, okay everyone? Chalo. And also we are having a mega offer for plus subscription. Like if you buy subscription for 12 months or more, you get free 2 months extension. Okay, and this is valid for first 500 subscribers. Chalo. So before starting the class, those who are present in the class, just confirm me once if I am clearly visible and audible to everyone. If everything is visible clearly and okay. So starting the class now. We have already covered few physical properties of water. Hello Meenu, welcome to the class. Thank you for confirming. Okay. So in the previous class of water, we have already completed your few physical properties like what is the nature of pure water, what is the boiling point, how your boiling point depends on pressure, why it is depending on pressure. Okay. Hello RSGN. Well, okay. Welcome to the class and thank you again. Okay. So, what is the density of water? Okay. Why water shows anomalous expansion? What is the reason for that? All these things we have already covered in the previous class. If you anybody of you having any doubt in these physical properties can ask me. Okay. So we are starting from the latent heat of fusion and vaporization. Okay. So the and specific heat capacity after that. So these three properties, physical properties of water is left. After that, we will start with water as a universal solvent. Clear? Now, what do you mean by latent heat? Okay. So latent is nothing but latent means hidden. Latent का मतलब होता है छुपा हुआ. Okay, hidden. So if any form of heat which we cannot see or which we cannot measure or perceive is known as your latent heat. Okay. For example, if you take water at 5 degrees Celsius, okay, if you have water at 5 degrees Celsius and you start heating it, okay, you start heating it. Now, if you put a thermometer in this water, okay, if you put a thermometer, this is the thermometer, and if you are continuously providing the heat to that water at 5 degrees Celsius, will you be able to see a rise in temperature or not? Yes or no? Please let me know if you know the answer. Means if you are heating it continuously, okay, so if you heat it, so do you see any rise in temperature? Will the temperature rise from 5 degrees Celsius to some other higher value? Yes or no? So you will see that yes, the water's temperature will increase to let's say 15 degrees Celsius after supplying some amount of heat. That means the heat that we are supplying here, it is visible. This heat is visible because the heat is shown as the temperature increase through thermometer. Okay. So this will not be your latent heat. Clear? This is not your latent heat. It is the normal heat. Now, for example, let's say we have ice, okay, which is at 0 degree Celsius. We have 1 gram of ice at 0 degree Celsius. We provide heat to this ice, okay, and what happens? This ice gets converted to water at 0 degree Celsius. Means if we will keep the thermometer in the ice box and if we are supplying heat to that box and converting the ice to water at the same temperature, you can see there is no increase in temperature. Yes, there is no increase in temperature. That means this heat is not measured here. This heat is not visible here. This is invisible heat. Okay, because this heat is not visible through rising through increase in temperature through thermometers, we cannot perceive it. This type of heat is known as latent heat. Clear? So where your latent heat will be involved? Wherever you have a phase change or state change. Clear? So if you have a phase change, so whenever there is a phase change or whenever there is change in the state, okay, whenever there is a change in the state, latent heat is involved. Okay, so latent heat is involved. Now what is the function of this latent heat? Why this heat is not visible to us? Why it cannot be perceived by any instrument? Okay, because this heat is used to break or weaken the bonds. Okay, weaken the bonds of the matter. Clear? So if you want to like melt solid to liquid form, so you need to weaken the bonds between the molecules of solid, then only it will be converted to your liquid. Yes? So latent heat is doing that work. That is, it is breaking or weakening the bonds of the matter to convert it to different state. Clear? Hello Zar, welcome to the class. Okay, so I hope it is clear to you. So latent heat, wherever you see the change in state, change in phase of matter, liquid to solid, solid to liquid, liquid to gas, gas to liquid. Okay, so if you see this state change, as understand that latent heat is involved here. Okay, and during your latent heat or during your state change, no change in temperature is seen. Okay, this type of latent heat are divided into two categories, that is your latent heat of fusion and latent heat of vaporization. Okay. Okay. Yes, Uzar, you are CBSE in your student life. Please tell. Okay. Uzar. Okay. Acha. I was a CBSE student personally. Okay. I was a CBSE student throughout my life. Okay. Yes, Uzar, I already answered your question. I was a CBSE student throughout my life. Okay. So, get back to the topic. So, I am just explaining here that we have two types of latent heat. That is latent heat of fusion and latent heat of vaporization. Now, what is latent heat of fusion? So, when you melt your ice at 0 degrees Celsius, 1 gram of ice at 0 degrees Celsius to 1 gram of water at 0 degrees Celsius. Okay, water, let me write it water only. I'm writing H2O. Here you can see ice to water is melting. And if you again convert water to ice, this is your fusion. Okay, so the heat involved here, the heat required to melt your 1 gram of ice at 0 degrees Celsius to 1 gram of water at 0 degrees Celsius and vice versa is known as your latent heat of fusion. Okay, latent heat of fusion. Is it clear everyone? Please let me know. But you teach in ICSE, why? Because of that I like ICSE means content, the content for ICSE till class 10. I love it. That's why I like to teach ICSE students. Okay. So, yes, everyone, please let me know. Is the latent heat of fusion clear to everyone? So, what is this latent heat of fusion? You should use specific whenever you are dealing with unit mass. Okay. So, if I talk about 1 gram of ice, so that will be your specific latent heat of fusion. So, what is your specific latent heat of fusion? This is the heat required to change one, or you can say to melt 1 gram of ice at 0 degrees Celsius to 1 gram of water at 0 degrees Celsius. This is your specific latent heat of fusion, or you can call it heat required to change 1 gram of water, or to freeze, you can write, to freeze 1 gram of water at 0 degrees Celsius to 1 gram of ice at 0 degrees Celsius. In both the cases, your latent heat of fusion will be same, either from ice to water or water to ice at 0 degree Celsius. Clear? Hello Navdeep, welcome to the class. Okay, so I hope it is clear to everyone what is specific latent heat of fusion, or in general latent heat of fusion. Okay, now if I talk about the specific latent heat of fusion for ice, okay, or for water, it is how much? So this is 336 joule per gram. That means you need to provide 336 joule of energy to 1 gram of ice at 0 degree Celsius to convert it to water at 0 degree Celsius. Clear? Is it clear everyone? Please let me know once. Please bring chapter sulfuric acid in one short class 10 ICSE. Navdeep, okay, sure. Okay. Please ma'am today. Navdeep, today to I have scheduled a class for hydrogen chloride already. Okay. But I can surely bring a one-shot session on sulfuric acid. Till then you can watch the previous sessions that I have already taken on sulfuric acid. Clear? So you can watch that, but today I have already scheduled a class, so it's very hard to change. Okay, but next session I will definitely try to do it on sulfuric acid and nitric acid as well, because one my student was asking for nitric acid also. Okay, chalo. So I hope this is clear to everyone. What is this specific latent heat of fusion? Yes. So that means you need 336 joule of energy to convert your 1 gram of ice to 1 gram of water at 0 degree Celsius or vice versa. Okay. Next, you have latent heat of vaporization. Okay. So latent heat of vaporization. What is this latent heat of vaporization? So vapors, okay, when you are converting your liquid to gas, that is your vapors. That means if you take 1 gram of water, okay, at 100 degrees Celsius, and you supply more heat to it, and without any change in temperature, you can see 1 gram of vapors are formed at 100 degrees Celsius. Okay, this heat will be termed as your specific latent heat of vaporization. Clear? So now why we are using specific for this particular phenomena? Because see here your unit mass is involved. So whenever you are talking in terms of unit mass, you need to use this word specific. Clear? So what can anyone tell me what is the specific latent heat of vaporization of water? Yes, specific latent heat of vaporization of water is how much? It is 2268 joule per gram. Means you need to provide 2268 joule of energy to 1 gram of water at 100 degrees Celsius to convert it to 1 gram of vapors at 100 degrees Celsius. Clear? Or you can say your 1 gram of vapors at 100 degrees Celsius, if it is condensing, okay, or vapors, or you can call it steam also, if it get condensed to form your 1 gram of water at 100 degrees Celsius, that will also be your latent heat of vaporization only, because your steam or vapors need to lose this much of energy to get converted to water again at 100 degrees Celsius. Clear? So this phenomena is what? This is your vaporization and this is your condensation. Okay. So for vaporization, water requires this much joule of energy, and for condensation also your steam required to lose this much, that is 2268 joule of energy, so that it can get converted to 1 gram of water at 100 degrees Celsius. Is it clear everyone? Please let me know once. So anyone having any doubt in particular topic, this one? Yes? Understood? Latent heat of fusion and latent heat of vaporization is clear to everyone? Okay. So now let's talk about your specific heat capacity. Okay. So specific heat capacity. Now I told you whenever we use this term specific, That means we are dealing with your unit mass. Clear? That means we are dealing with your unit mass. Now, what is this specific heat capacity? Okay. Now, let's say we have a particular weight of water. Okay. Let's say we have 10 grams of water, or let's say we have 1 gram. When we are talking about specific, when we are using this term specific, we have unit masses. So that let's say we are taking 1 gram of water. Now this 1 gram of water, let's suppose it is at 5 degrees Celsius. Okay, you have 1 gram of water at 5 degrees Celsius. Now, how much heat should you provide to this 1 gram of water so that its temperature increases by, okay, your temperature increases by 1 degree Celsius. Anyone in the class can tell me this, okay? So if you have 1 gram of water at 5 degrees Celsius, what is the exact amount of heat that you should provide to this 1 gram of water so that it gets converted to 1 gram of water at 6 degrees Celsius? Means to increase your temperature by 1 degree Celsius. Increase temperature by 1 degree Celsius, how much heat you need to give it. Now, it was found that your 1 gram of water always absorbs 4.2 joule, 4.2 joule of heat energy to increase its temperature by 1 degree Celsius. Okay. So, if you want to increase the temperature of 1 gram of water by 1 degree Celsius, you need to give 4.2 joule of heat energy. That is a very high quantity. Okay. That means your water has a very high specific heat capacity. Clear? So how can you define this specific heat capacity? So specific heat capacity is the amount of heat absorbed by 1 gram of water to increase its temperature by 1 degree Celsius. This is the specific heat capacity. That means your 4.2 joule is the specific heat capacity of water. Clear? It is the specific heat capacity of water. Now, water has a very high specific heat capacity. That means water is a poor conductor of heat, you can say. Clear? Now, your water has a very high specific heat capacity, due to which it can modify the climate. That's why your coastal areas are warmer in the winter. Is it clear, everyone? That's why the coastal areas are warmer in the winter and they are cooler in the summer. So due to this high specific heat capacity of water, they have the ability to modify the climate. Okay? To modify the climate. Clear? That's why your any city which is located on the beach, on the side of beach, or on the side sea, I want to say. So on the side of sea or any water bodies, those cities are relatively warmer in winter than the other cities which are not located on the bank of any sea or ocean or river. Clear? So how your water is able to modify the climate? So basically the ability of water to absorb your heat energy to increase its temperature by 1 degree Celsius. So you can see 1 gram of water requires 4.2 joule of energy to increase its temperature by only 1 degree Celsius. If your so much of water is there, so that water can absorb a very high amount of heat energy during the daytime, and that heat energy is only radiated during the night time, which makes the climate warmer during the winter season. Clear? In such a way, your water can modify the climate. So I hope it is clear to everyone. And so let's just revise a few things. Okay. So specific heat capacity of water is 4.2 joule, or you can call it 1 calorie. If you talk about specific latent heat of fusion, these values you need to remember, okay? Because these are very important values. This is 336 joule per gram, or you can call 80 calorie per gram. If I talk about specific specific latent heat of vaporization, okay, latent heat of vaporization, this is 2268 joule per gram or 540 calorie per gram. Clear everyone? Anyone having any more doubts in this particular thing? I hope it is clear. Now, let's talk about, like, water is a universal solvent. Means water can dissolve, I think so, many substances. Okay. Almost all substances forming aqueous solutions. Okay. Hello Shreyash. Thank you so much. Okay. Thank you so much. Welcome to the class, Shreyash. So, I hope you are getting everything, whatever I am teaching in the class. So, if you have any doubt, you can ask me. Chalo. So, water is a great solvent. Now, why water is such a good solvent? Why so many substances can dissolve in your water? Okay. So, basically, water has a high dielectric constant, due to which it becomes a very good solvent. Now, what is this term, dielectric constant? What is this? Okay. Now, try to understand in a very simpler way, because you are going to study this term in your class 11 first chapter current electricity. Sorry, class 12 first chapter current electricity. Okay, in physics. But for now, I would like to explain it in a very simpler way. Try to understand in this way. So all of you know this, that water is a polar solvent. Yes or no? Water is a polar solvent. I have already spoken about this polarity in the previous class. If any one of you is not getting this term, can tell me in the comment section. I will re-explain it. Okay. So water has a, what is a polar solvent? Okay. Now, water itself is a polar solvent, and the molecules of water are sticking to each other with a great force of attraction. Okay. Now, water has a specific ability. Water has a specific ability. Now, what is that ability? Water can decrease the electrostatic force of attraction between the cations and anions of any solute that is being dissolved in the water. Once more, okay? So, for example, if you take like NaCl and if you want to dissolve it into water. So water, since it is a polar solvent, what it has the ability, it will decrease the electrostatic force of attraction that is existing between your Na plus ion, Cl minus ion, due to which your Na plus and Cl minus will get separated from each other, and hence they will get dissolved inside the water. Let's try to understand how. Okay. So I told you why water has very high dielectric constant, because of its strong bonds between hydrogen and oxygen. Okay. And also because of the force of attraction between the water molecules, that is known as hydrogen bonding, about which I have already explained earlier. Okay. So water does not ionize also. Okay, because the strong charges that molecules have on them, or the atoms inside the water molecules have on them, these strong charges are tightly bounded to each other in the molecule. That's why water cannot ionize. Clear? But it can decrease the force of attraction between the ionic compounds. So basically what happens here, just try to understand it like this way. NaCl is there. Now water, it will get dissolved into water. So what will happen? This water will decrease the force of attraction that is between your Na plus and Cl minus. So this decreases. Water, your H2O, decreases this force of attraction, or electrostatic force of attraction, I can say, which is responsible for forming this ionic bond. This ability to decrease the electrostatic force of attraction between the ions of the solute is known as your dielectric constant. Okay, this is the dielectric property. So water has, the dielectric constant of water is 81. Okay. The dielectric constant of pure water is 81. That means it can decrease the electrostatic force of attraction between the two ions by 81 times. Okay, what does this mean? That your water can decrease the force of attraction between the ionic solutes by 81 times. Okay. And what happens now? This Na plus is there and Cl minus is there. So due to the decrease in the force of attraction, they get separated, and now the water molecules will come like this. So all of you know water is a polar solvent. So it has delta positive, delta negative, delta positive charge. So these all oxygen atom will encircle, okay, all the oxygen atom of the water molecule will form a bond. It will encircle the sodium ion in such a way that it will not go back and form the bond with your chlorine ion. Clear? In this way. And your chlorine ion will be surrounded by your hydrogens of the water molecule, so that it does not go back again to your sodium ion and forms a bond. And in this way, water molecules forms bond with your cation and anion of the solute, and hence they are soluble in water. Clear everyone? Just let me know if it is clear to everyone. Okay. So anyone is present in the class? Shreyash, Uzad, Navdeep, Meenu, RSGN, Shaurya. Anyone would like to tell me if it is clear or not? Okay. So all of you must see this, that due to its high dielectric property, okay, water is able to dissolve almost all substances, forming an aqueous solution. Clear? So water reduces electrostatic force of attraction between the positive and negative ions of the solute and can dissolve even your inorganic compounds. Clear? So I told you that in a solution, water molecules will surround both anions and cations, and thus it minimizes the attraction between the two charges. And what does this statement means? That dielectric constant of pure water is 81. That means it can decreases the electrostatic force of attraction between the any ions of the solute by 81 times. Clear? Now, and for this reason only, okay, it is very difficult to find pure water in the nature, because water will dissolve your solids, liquids or gases as well, and that's why water is known as a universal solvent. Clear everyone? Shreya, are you there in the class? If you are there, please let me know if it is clear to you. Yeah? I hope everything is getting clear to everyone. Chalo. Let's talk about the solubility of air in water. Okay, so I told you that water can dissolve your inorganic compounds, organic, okay, your ionic compounds. Okay, so gases also get dissolved inside the water. Clear? So the gases that are present in the atmosphere are dissolved in the water due to the pressure exerted by them on the surface of water. Okay, so solubilities. Now, what is solubility? The ability of the gas to get dissolved in the water. Clear? Now, what is solubility? Ability of gas to dissolve in water. Now, this solubility of separate gas is different. Now, carbon dioxide will have different solubility, nitrogen will have different solubility, oxygen will have different solubility. Okay, so different gases have different solubility. And how much gases, okay, so how much gases will dissolve inside the water, it will depend upon the pressure of the gas exerted on the surface of the water. Clear? Now, all of you know this, in air you have two major components. That is your oxygen and another is your nitrogen. Now, all of you must be knowing this, that solubility of oxygen in water is higher than the solubility of nitrogen. Okay. Now, if you calculate the percentage of oxygen, nitrogen and other gases in air, your ordinary air will contain 33% of oxygen. Sorry, your ordinary air will contain 21% of oxygen. Yes, 21% of oxygen in air is present. But the air which is dissolved inside the water, it is containing your 33% of oxygen. Clear? So the air which is dissolved in the water is having different composition of oxygen and nitrogen than the air that is there. Okay, the ordinary air, the air in which we are breathing. Clear everyone? Just let me know if it is clear to all of you. Yes? Sure. So oxygen is more soluble in water than the air. Why? Because of the formation of hydrogen bonding between the molecules of water. I told you when your hydrogen bond is formed, whenever your hydrogen is bonded with more electronegative atom, then you can find hydrogen bondings. Yes, so oxygen can form hydrogen bondings. That's why your oxygen is more soluble in water than your nitrogen. Clear? And you must be knowing this phone means oxygen is more electronegative than nitrogen. That means oxygen will have more stable hydrogen bonding than nitrogen. That's why oxygen gas is more soluble than nitrogen. Okay. So you can see the concentration of oxygen in water is more than that of your air. Okay. Clear everyone? Is it clear? So like you have 33% oxygen in water but 21% in ordinary air. 66% nitrogen in water but 78% in ordinary air. Okay. And carbon dioxide you have 1% in water but in air you find in something in point. Fractional percentage is present. Okay. Clear everyone? I hope it is clear. Now why we need to have dissolved air in the water? Why we need to have different gases dissolved in the water? So these gases have many advantages like your marine life. They utilize the oxygen that is dissolved in the water for the respiration. Also your aquatic plants, they utilize the dissolved carbon dioxide for preparing their food, that is for photosynthesis. Okay, and your dissolved carbon dioxide, it forms your calcium bicarbonate which is utilized by the marine organisms to build their shells. Like your snail, oyster, all they have shells that is made up of your calcium bicarbonate. So okay, so calcium carbonate and bicarbonate is also formed due to the dissolved carbon dioxide in the water. So these are the different advantages of your dissolved gases that are found in the water. Clear everyone? I hope it is clear to everyone and no doubt is there no one is having any doubt. If you have any doubt you can let me know. Clear? Chalo. So I hope it is clear to everyone. Now just give me a moment. So now we talk about solutions. Okay. What are solution? Okay. So this is going to be the last topic of today. After this we will start our MCQs. So what are solutions? Okay. So solution is nothing but a homogeneous mixture. Homogeneous means uniform composition. Okay. Uniform composition and properties. This is the meaning of homogeneous. For example, if you take a solution, okay, which is a homogeneous solution. So if you want to take 10 ml from this part, 10 ml of solution you have taken from this part and 10 ml of solution you have taken from this part. Clear? So let me tell you, if you take these two means 10 ml of solution from two different parts, will they have same properties? Will they have different properties? Will the concentration of solute in the 10 ml is same, or the solute in this 10 ml will miss both 10 ml will have same amount of solute? So what will be the composition and concentration of solute in these two parts which I have taken from the solution? Please tell me. Hello Suman, welcome to the class. Ma'am, my tuition teacher is online physics. Okay. So, all of you must understand this, okay? That both of these parts, that let us name this part as A, this one as B. So, your A and B will have same properties, okay? And same concentration of solute. Clear? So because we are taking same volume of solution from two different parts of solution, okay, from two different places of solution. So both will have same properties and same concentration of solute. That means this solution is showing your homogeneous properties. Clear? Okay, Suman. Chalo, very good. So this is the meaning of homogeneous. Now solution can be a homogeneous mixture of two or more components, okay, and in which your particle size, when we talk about solution, we are talking about true solution, and true solution always have particle size, that is a particle of the solute will be smaller than 1 nanometer. Clear? Now, the composition of solution, you can change the composition by changing the amount of solute, by changing the amount of solvent. You can change the composition, you can make it dilute, you can make it concentrated. Okay, that we will study in few minutes. Clear? Now, why we are telling the solution as a mixture and not a compound? Why it is not a compound and only told as mixture? Because the components which are making the solution, which are forming the solution, they are mixed in any ratio. There is no fixed ratio of mixing them. Okay. If I ask you to prepare 1 glass of salt solution or sugar solution, let's say. Okay. So if you are a person who likes more sweetness, okay, will prepare such a solution in which you have more sugar in dissolved in the same quantity of solvent, let's say. Okay, and I am a person who does not like so much of sweetness, so I will put less of sugar in the solvent. That means both of us are making the sugar solution only, homogeneous solution only, but it is not fixed that to prepare a sugar solution you need to put this much spoon of sugar. Okay, that means you can have the mixture prepared in any ratio. That's why your solution is simply a mixture and not a compound, because the components that are forming the solution, they are only mixed. They are not chemically combining with each other. There is no chemical reaction taking place over here. Clear everyone? Just let me know once if it is clear to you. Yeah? Okay. And bacha, if you're really liking the classes, no, please do share and like the classes so that maximum students can join us on this platform. Okay? Chalo. So I hope it is clear to everyone. Now, the solution, the components that are present in the solution, they lose their individual properties, okay, and they cannot be separated by simple filtration method. Of course, like sugar, if you put in water, it will lose its solid state. It will be means it will have the properties of the solution. Your water will also lose its individual identity, and it will they make the part of the solution. That means the components that are present in the solution, they will lose their individual properties and will attain the properties of the solution itself. Clear? I hope it is clear to everyone. And the solution, okay, if you are having a solution and you can remove the solute from it by simple filtration method, by decantation and sedimentation and all, then that is not your solution. Clear? So in solution you cannot be able to separate the solute from solvent by simply filtering it. Yes, simple filtration technique will not work here. So I hope I have made my points all clear to you. Okay, and you don't have any doubt in any of the topics. So let's start with the MCQs. Okay, so let's understand what you have understood from this particular uh, class today. So first question that we have is, which property of water enables it to modify the climate? Specific heat capacity, latent heat of fusion, latent heat of vaporization, or all? Anyone? Suman, Shreyash, Uzar, RSGN, anyone? Okay, can you answer it? Tell me fast. Okay. Chalo. So if you are really liking the classes, please do not forget to like the class as well, okay, and share it with your friends, okay. So I told you specific heat capacity is the property of water which enables it to modify the climate, okay. Next question. What is the importance of dissolved salts in the water? Dissolved minerals and salts are essential for the growth of plants. Dissolved salts add taste to the water. Dissolved salts and minerals in water provide essential minerals required for our body, or all of the above are correct. So please let me know if you know the answer. What is the importance of dissolved salts in the water? Anyone who would like to answer it? Okay. So basically your dissolved salt is essential for the growth of plant. This is correct. Dissolved salts add taste to the water. This is absolutely correct. Dissolved salts and minerals in water provide essential minerals required for our body. This is also absolutely correct, and all of the above is the correct answer over here. Clear? I hope it is clear to everyone. Next question. What is the effect of impurities present in water on boiling point of water? Increases the boiling point, decreases the boiling point remains the same, or none? So please let me know if you know the answer. And do not forget to like the class everyone, please. Okay? Chalo. So what is the effect of impurities present in water on the boiling point of water? Yes? Tell me fast. Anyone? Okay. So I'm going to give the answer here. If you have impurities present in the water, your boiling point of water will increase. Okay. Because the impurities will have their own boiling points and water has its own boiling point. So to boil the overall liquid, you need to boil the impurities as well. That's why you need to provide more temperature. Hence your boiling point will increase. Clear? So, mixing or presence of impurities in water will eventually increase the boiling point. Is it clear everyone? Please let me know. Okay? Chalo. I hope it is clear. Now, next question. When a solid changes into liquid, it absorbs heat dash to the latent heat of fusion. Okay. So if you are converting a solid to liquid, it is absorbing heat dash to the latent heat of fusion. Lower, higher, equal, or none of these. So please let me know if you know the answer. Okay. Answer it everyone. Okay. So I'm going to answer it here. It will be equal. Okay. So if you want to change your solid to liquid, it will absorb heat equal to the latent heat of fusion. Next. The homogeneous mixture of solute and solvent is called dash. Salt, solution, compound or mixture. What do you call the homogeneous mixture of solute and solvent? Anyone? Okay. So I hope, okay. So here the answer is solution. I told you just now that if you have a homogeneous mixture of solute and solvent, it is called solution. Okay. Now, Which of the following are deliquescent substances? Okay. Glauber salt, calcium chloride, copper oxide, ammonium chloride. Which of the following are deliquescent substances? Anyone in the class? Glauber salt, calcium chloride, copper oxide or aluminium chloride? Tell me fast if you know the answer. Yes? Okay. So all of you understand this now. What are deliquescent substances? Like deliquescent substances are those which absorb moisture from air and dissolve in the moisture, in the absorbed moisture I must say, to form a saturated solution. Okay. Now, out of the given options, which is a deliquescent substance? So the answer is calcium chloride. Okay. So calcium chloride is a deliquescent substance. Is it clear everyone? And this Glauber salt, this is a efflorescent substance. Okay, this is a efflorescent substance. Clear? So I hope it is clear to everyone. Okay. Now, which of the following absorb moisture from air? Which of the following will absorb moisture from air? Green vitriol, common salt, soda ash, both A and B. Which is the correct one here? Anyone? Okay, and do not forget to like the class everyone. Okay. I hope it is clear to everyone. Okay. So, here the correct answer is your common salt. Okay. So, basically your common salt will absorb the moisture from air. Next question. What is blue vitriol? Out of the given options, which one correctly represents the chemical formula for blue vitriol? Okay. Which one is blue vitriol? Anyone? Tell me fast if you know the answer. Okay. So basically your blue vitriol is copper sulfate pentahydrate. This is your blue vitriol. Okay. And this is your green vitriol. Clear? I hope it is clear to everyone. Just let me know if it is not clear to anyone. Chalo. Now, burns caused by steam are more severe than the burns caused by boiling water. Why this is so? Due to latent heat of vaporization, due to latent heat of fusion, both A and B or none. So if anybody knows the answer, please tell in the comment section. Okay. Sure. So this is going to be the answer A as the correct option. So your steam contains latent heat of vaporization that is equals to 2268 joule of energy, which is causing more severe burns by the steam than your boiling water, because boiling water does not contain your latent heat of vaporization. Is it clear everyone? Please let me know once if it is clear to everyone. Yes? Okay, chalo. Now, So all of you, there's a good news for all of you. Those who have missed the Unacademy Prodigy test, so you can see over here, your Unacademy Prodigy test is extended on to 27th of Feb. The timing is from 12 p.m. to 1 p.m. You can enroll now yourself just for free, and do not forget to use my code Manisha Live. So those who were upset because of missing of this Unacademy Prodigy test, because you have missed your Unacademy Prodigy test, so do not worry, Unacademy has extended the Prodigy test, that is on 27th of Feb. Okay, and you can win prizes up to 10 crore. But I always tell you, there is another side of this test, that you can always analyze your preparations level and your competition with this test. Okay, so do enroll now yourself using the code Manisha Live. And let me tell you about the ongoing batches, that is for class 9. We have champions batch where your India's top educators are taking the classes. Okay, and you can always join this batch with a single subscription that you have to take for plus subscription. And we have same like batch, Udan batch, which is for class 9, where your everything will be taught in Hindi. Okay, so you can join these batches always, and you can always avail the best advantage. You can always be one step ahead of your competitors with the best preparation that an academy provides you with the plus courses. Okay, means you can have really, you can really enjoy the preparation with method. You can solve all your doubts, everything will be solved here. Okay, so please go for these subscriptions. And if you want to now know about your preparation journey, subscription queries, if you have, if you don't know about the latest offers, okay, also for now we have a latest offer that instead of 10% you are getting 20% discount. Okay, to get this 20% discount, please do not forget to use my code Manisha Live, which will give you 20% discount straight on the plus subscriptions. Okay, so do take the subscription, and you can just call on this number and you can solve all your queries and take the subscription as soon as possible, and meet me in my plus class, that is at 6:30 p.m. on Tuesday, Thursday and Saturday for class 9. Okay, so thank you everyone for watching the session live. So I hope you liked the session. And if you want to watch my next session, if you want to connect with me whenever I go next live on this channel, so do not forget to subscribe to this channel and hit the bell icon so that you receive the notification of the class as soon as it starts. Okay, you can download the PDF format, PDF note of this class from the Telegram channel, whose link I have given in the beginning of the session. Okay, so thank you everyone. Do not forget to like the class and share the classes with your friends. And yes, tomorrow again we will come live at 2 p.m. So do not forget to join that class as well. Okay, so thank you everyone. Thanks a lot. Thank you. Bye. Take care. Okay. One more thing. One more thing that you ma'am, your last sulfuric acid was according to reduced syllabus. Yes, Navdeep, the last sulfuric acid was according to reduced syllabus. You can watch that session. Okay. Chalo. One more thing I would like to tell you all of you, that we are having sample question paper solving for class 9 students tomorrow at 8 p.m. in the night. Okay. So do not forget to join that session where I will be solving your sample question paper released by ICSE boards. Okay. And do not forget to share that session with your friends tomorrow 8 p.m. Okay. Thank you everyone. Bye. Take care.